right, this is going to be number 2. Number 2 in our notes. So if you haven't put number 2 yet, please go ahead and put that. All right. I want to go ahead and talk to you real quick because I know you've got the worksheet in front of you and some of you are tempted to work ahead. All right. Now, guys, here's the deal. I need everyone listening. All right. Today, our learning target is I can solve a one-step equation. All right. Guys, y'all are very intelligent 6th graders. I am well aware that you can do one step in your head. I am well aware that the majority of these problems you can look at and determine the answer. What you are not aware of is that in the 7th grade and in the 8th grade, you will no longer be doing one step. You'll be doing 2, 3, 4, 5 steps. Okay? In order for you to be able to easily do those, you need to be able to have mastered the layout for how to do one step. Okay? We've got to be able to do that. Which means I don't need it in your head. I need it on the paper. Okay? When we're solving these one-step equations, please remember an equation has to have an equal sign. Guys, the most important thing about an equation is the equal. Well, not the most, but it's really important. Okay? All right. When we're solving these one-step equations, we have one goal in mind. All right, so at the top, if you will write what our goal is, we're going to write it together. We have one goal. Oh, you cannot see that. We have one goal. Our goal is to get the variable alone. We need to get the variable alone. We need to get the variable alone. In order to do that, we're going to use some tools. Some math tools, if you will. In order to get the variable alone, we are going to use something called inverse operations. All right, and that's a very important term, so we're going to underline that. All right. We need to make sure we're writing this down at the top of that paper, please. Inverse operations, it's just a fancy sounding way of saying opposite operations. So, for example, what is the inverse of addition? What is the inverse of addition, Jacob? Subtraction, because that's the opposite. Right? What is the inverse of multiplication? Addison? Division. Right? Now, the main reason that these are super helpful, we're going to put a little star here. Right? The main reason these are super helpful is because inverse operations, I don't know why I put 2 P's there, operations cancel each other. Inverse operations cancel each other. All right, that's the last thing that we're really writing, so make sure we have that written down. Okay. So inverse operations are opposite, so adding and subtracting and adding, multiplying and dividing and multiplying. And the main thing there is because adding will cancel subtracting. Subtracting will cancel adding, and we're fixing to see that work in just a moment. All right? When we're setting up, does everyone have that copy? Okay. When we're setting up equations, it's very important that we have 2 sides. So it's kind of like fractions, how we have tops and bottoms. On equations, we're going to have a left side and a right side. What do you think is going to split that equation? Addison?
A line.
A line? And where would I want to draw my line? Can I just like draw it down the middle of the 6? Where would be a good place to draw the line? Cruz? Okay, so our plus sign seems like that might be a good way to split it. Now remember, that plus sign, does that mean, is that separating my problem? Y and 6, do they need to be separate? No, because I'm actually doing something with them, right? So where would I have a good separation? Ella? They equal, because y plus 6, that's like something that I do. And then it equals 20. Do you see how those are two separate things? Y plus 6 is an action. 20 is an answer. Y'all see that? All right. So what I want us to do, guys, is I want us to draw a line where that equal sign is. We're going to split it. So now I have the left side over here, and I have the right side over here. Do y'all see that? Now, when we say that we have to get that variable alone, we're talking about on the right side. Y has to be, left side. Y has to be alone on the left side. Is Y alone right now?
No.
No. Y has a friend over right now, 6. 6 is hanging out with Y. We don't want 6 hanging out with Y. We want 6 by itself. Okay?
That's sweet.
Friends.
Well, no, Y.
Y has no friends.
Yeah, okay. Y is not allowed to have any friends, okay? So, getting carried away. Love y'all. Getting carried away. Thank you. All right. So we have this plus 6 that we need to get rid of. Again, what is our tool? What are we going to use? Jesse?
Inverse operations.
Inverse operations. Excellent. So what is the inverse of plus 6? Julia? Minus 6. So I'm going to write that underneath. Minus 6. All right. Now here's the thing about equations and this pesky equal sign. It's kind of like those balancing weights. If you put something on one side, you have to put it on the other. So if I'm going to subtract 6 over here, for it to stay equal, you got to subtract 6 over here too. Okay, have I lost anyone yet? And then this is, I'm just drawing a line because usually when we do subtraction, we do a line to do our work, right? Okay, so here's the cool thing. Plus 6, minus 6. They are inverse operations, correct? So they are going to cancel. They are gone. Also, think about it. What's 6 minus 6?
0.
0. Guys, does adding a 0 or subtracting a 0 do anything for me? Nope, it doesn't. Yes. Owen?
Can you just, like, you see, like, 6 plus y equals 20, and then you just take a 14 and then just...
Oh, excellent. Yeah, I know. You can look at this and see 14. I'm so glad you brought it up because I didn't mention that you'd have like 5 steps, in 7th or 8th grade. Didn't say that at all. So let's talk about a problem that you can't just look at. Okay, now, can you look at that and tell me what y is? Can you look at that and tell me what y is? No, not going to work. Guys, again, I appreciate, guys, I know you can do one step in your head. I know you can look at these and see your answer. This is where you're going. You've got to know the first step so that when you got to do all of these, which is only 1, 2, 3 steps, that's only 3. That's only 3. You got to know the first one, though. Does that make sense? So I'm not trying to, I know that y'all are very inquisitive. I love it. That we have lots of questions. But when I tell you, you got to show this step because eventually you're going to have more. All right? And y'all know there's going to be times where you just can't look at a problem. Y'all know we start easy. All right? Real quick. No, it's not. All right, to find this problem, we would have to do all the inverses. This is division. The opposite of dividing is to multiply. You'd multiply by 15. The opposite of adding is subtracting. Then you would subtract the 3. The opposite of multiplying is dividing. Then you would divide the 7. Guys, we are not here yet. We got to do one step. Can we go back to that, please? Okay. All right. So going back here again. All right, got my math team folks, I know we've done this. We've been doing that since like November, okay? I know y'all got that, okay? You have to show this step. Guys, this is the foundation for every math class that you're going to do algebra in, which is pretty much all of them. Even when you do geometry in the 10th grade, guess what? You still do some algebra with it, all right? You've got to be able to show that first step. Next year, you're going to add more, all right? Are there any questions on where I got minus 6 from? All right, so Owen, I'm going to go back to that. If you just write 14 plus 6 equals 20, so y is 14, you will get 0 points on your homework. My goal isn't, they know their addition facts. Oh, they know their multiplication facts. That's not my goal. My goal is that we're subtracting 6 from both sides of that equal sign. Okay? Do we understand that? All right. So right over here, now that those 6's have canceled, what's left over there? The y. Andrew, I'm going to finish this problem real quick, okay? And then we have 20 minus 6. What does 20 minus 6 give us? 14. All right, Andrew, now I'll answer. What was your question?
So my question was, you see how it says like y plus 6 equals 20. What you could basically do is have the opposite, like addition is the opposite of subtraction. So you put 20 minus 6, and then that gives you the answer. Yeah.
That's what we just did here. 20 minus 6.
But could you just like flip the problem?
No. No, you cannot just flip the problem. Guys, you're not just going to have one operation. You're going to have 5, 6 operations. You've got to know what to do with the first one before we can add to it. I need your work to look like this. I need you to do it to both sides of the equal sign. The whole point here is what I do to one side, I have to do to the other. I just can't say, oh, I'm going to take 6 away from the 20. Well, okay, now it's not equal. You can't just say to take the 6 away from the 20. We've got to show that it's happening to both sides. That's the reason that y equals 14. Okay? If I just do it over here, then you're saying y plus 6 equals 14. Well, that's not the case. We've got to take it away from the other side as well. All right? Let's look at the next one. It says x plus 10 equals 12. X minus 10 equals 12. I've already split it. On the left side where we have x, is x by itself? No. What is with my x, Mark? A minus 10. What is the inverse of minus 10, Lily? Plus 10. So I'm going to do that to both sides. We have to do that to both sides. What happens to a minus 10 and a plus 10, Sadie?
They cancel each other out.
They cancel out. So what's left over here? Sadie?
Oh, you got your x.
My x. And then remember that bar is just keeping my equal sign in the center because my equal sign has to stay there. All right, and then 12 plus 10 is 22. So there's my answer. All right. The next problem. The next problem is a little bit different. This says 12 plus z. So this time I'm not adding or subtracting a number. I'm adding the variable. Do y'all see that? The plus sign here is going with the z. So we need to still figure out how to get rid of the 12. Can someone tell me what type of number is 12? What type of number is 12? Addison? It's a positive number. Do y'all all agree with me that 12 is positive? Yes. All right? Because 12 does not have a sign in front of it, I know it's positive. Now, it doesn't have a sign, but could I put one?
Yes.
What could I put in front of 12 since it's positive? Ashton? A plus sign. A plus sign. So now it's plus 12. So now is it more obvious? What am I going to do? What is the inverse to get rid of the plus 12? Amelia?
You're going to put plus 12. I mean minus 12.
Minus 12. Inverse. Opposite. Minus 12. And then if I do it to one side? Do it to the other. All right, what happens to my plus 12 and my minus 12? Jesse?
They cancel out.
They cancel out. And what's left over there? Z. Now, it does say plus Z. Now, here's my question. If those are gone, am I actually adding the Z anymore? No, they're gone. So what that plus sign is really saying is, oh, it's just a positive Z. Well, remember, do I have to have a positive sign? No. Since it's not a plus sign anymore, it's positive, we're just going to bring down Z. So if it was a minus sign, would I need a negative sign? Yes, negatives can't just disappear. Plus signs aren't necessary for positive. Okay? All right. What do I get? 15 minus 12. Brittany? 3. All right. 3. Okay. Questions about that? All right. Just going to reiterate. Y'all are great. I love y'all. I love how inquisitive we are. Sometimes when I teach a lesson, I get a little testy, so I'm sorry. So thank you for your questions. Did I sate everyone's curiosity about this stuff that we're showing? Okay, all right. All right, let's flip it on the back, guys. We're flipping it on the back. Guys, what's so great about this is once you've mastered that one step, it applies to every type of problem. All right? Guys, when you're doing 5 different steps, guess what? They're all going to look the same. You're still going to do one side and the other side. What I do to one side, you're going to do to the other side. the whole way through. Just sometimes your problems are going to be a lot longer. These are going to be short and sweet. All right, so there's my equal sign. I'm going to draw my line. My variable is on the left side. Is my variable alone on the left side? No. What's with my variable right now, Amelia? It's a 2. But what's happening with that 2? What operation is that? It's multiplication. Do we agree if they're right next to each other, it's multiplying? So what's my inverse going to be, Ben? Dividing. All right, now here's the thing, guys. Y'all remember this division symbol that you've used a lot? All right, remember at the beginning of the year I said, hey, enjoy it while it lasts because eventually I'm not going to take it anymore. We are there. Today is the day. Do not use that symbol. Do not use that symbol. So how are you going to show me your division? If I'm not going to allow this, how are we going to show that division? John? As a fraction. So I'm still going to put divided by. I'm just reading that as a fraction bar.
Why are we allowed to use that?
Because it's going to become completely irrelevant. So you're going to get to the point where in math class you don't use it anymore. So let's go ahead and get used to it. All right? Guys, we're getting into algebra. Y'all, I love it so much. So I want us, we're going to do grown-up math for a while. Okay? I know. All right? So I want us to get rid of this. Get rid of this little thing. All right? Use your fraction bar. All right? Sorry. I love y'all, but I'm pushing y'all, okay? Because I love y'all so much, I want us to see what's going to be used in all of our future math classes. So let's go ahead and eliminate that. Okay? All right. So here we were multiplying by 2. So what am I going to be dividing by? Jesse? 2. And if I do it to one side? And that means dividing by the exact same number. So we're dividing by 2 there as well. All right? A times 2 and a dividing by 2 are inverses. So what's going to happen there? Neely? They're going to cancel out. All right, now I do want to mention something real quick. These aren't canceling out because they're 0 anymore. Because what is 2 divided by 2 going to give me?
0.
2 divided by 2 is not 0, guys. Come on. 1. 2 divided by 2 is 1. We can still do division, right? Okay, 2 divided by 2 is 1. And guys, how would I write a 1x? X.
Oh, okay.
Okay, so guys, we're still just going to mark it out. I just want us to cognitively be aware, hey, it's not marking out because it's 0 anymore. This is marking out because 1x is just x. All right, and then 16 divided by 2? 8. Excellent.
Yes.
All right. Number 20, we have 15 equals 3t. There's my equal sign, draw my bar. This time, what side is my variable on? Jesse?
The right.
The right. Guys, don't just go flipping your variable around. We're going to work it with it on the right, and it'll be okay. We're going to work it with it on the right, and it will be okay. All right. So on the right, we have 3t. Is t by itself? Sadie? No, what's with it? The 3. What's my operation? Multiplication. What's the inverse? Division. Next person, how am I going to show my division? Mo?
Using a fraction.
Fraction bar. And what am I dividing by? Owen? 3. And if I do it to one side? All right, so let's look over here. Starting on the left side, 15 divided by 3 is?
5.
5. That line is where my equal sign goes. Guys, if you don't have an equal sign in your answer, you have not told me what that variable equals. See what I'm saying? So make sure you got that equal sign, okay? 3 divided by 3, those are going to cancel. So what am I left with? T. Okay. All right, the last one that we're going to work together, and then we got one more thing that we got to do to these problems. Love y'all. Okay. We have k over 2 equals 3, or k divided by 2 equals, 6. 6. Okay. I'm going to draw my fraction bar. I'm going to split it. Draw my line to split it. Oh, my fence. Thank you. That's what I called it in math team. We talked about fences a lot. Okay. All right. So in this problem, is my variable by itself? No, my variable is not by itself. What do I have with it? Jesse? A 2. I have a 2 with it. All right. So what operation is happening with that 2, Amelia?
Division.
It's division. Now, guys, this is really important. What is actually being divided by 2? k. So guys, when I do that inverse, would the opposite of dividing k by 2 be to multiply 2 times 2? No. The opposite of k divided by 2 is k times 2. Alright, you can also write it like in front, so like 2k. Isn't that k times 2? 2k? Alright, so it's important, guys, when you do your multiplication, am I doing my multiplication on the bottom of that fraction? No. It's going on the top. Remember, k divided by 2, the opposite is k times 2. So that 2 has to be with the k. Do we see that? Alright, if I do it on one side, do it the other. So I'm going to put times 2 over there. And I'm just using the dot for my multiplication symbol. You could put it in parentheses. Right? A 2 on top and a 2 on bottom. What's going to happen to those? They're going to cancel. Do you notice, guys, every time I cancel, I'm always going like in a downward motion? If you're ever canceling going side to side, you know you're doing something wrong. All right? Even here, I'm canceling going up and down. Do y'all see that? All right. So what's left over here? Okay. Equals. Make sure we got our equals. And then over here? 12. 12. 6 times 2 is 12. All right, so that's awesome. Guys, that should set you up to work the rest of the problems, but we're not done. We're not done. We're not done. Because it didn't just say to solve the equation. It said we must show our work. And then it also said to check your answer. That sounds like such an exciting groan. I'm going to take it as a good thing. Okay. All right. When we check it, guys, I'm going to put a little check mark because we got work for that too. All right, so I'm going to check mark. This is where I'm checking it to see if it's right. Guys, this is super beneficial. If you can check all of your answers, is there a reason to turn in a test and get anything less than a 100? Not if you checked them all. Not if you checked them all, because then you can go back and fix them. All right, what did this problem on number 1 originally say? Andrew?
Y plus 6 equals 20.
All right, so that was my original problem. All right. Still splitting it at that equal sign. The only side I want to work on is this y plus 6 side, okay? So where we have y plus 6, what did we find that y actually is? Brittany? 14. Here's where we had our answer. Guys, y equals 14, that's still my answer. All right, but what I want to do is check it. So I'm going to change this y to 14, and 14 plus 6. All right, can someone tell me what is 14 plus 6? Neely? 20. Do these two numbers match?
Yes.
Yep, so that means check, we got the right answer. Okay. All right, so let's check the next one because we're going to check our homework. All right. So we have x minus 10 equals 12. That was my original problem, right? Again, I'm only looking on the side where my variable is. What did I find my variable was in my answer? Jesse?
22.
22. Y'all see where that was? There's our answer. Okay, I'm going to plug that in. So now instead of saying x minus 10, it says 22 minus 10. What is 22 minus 10? Mark? It equals 12. Now, guys, you actually have to do that subtraction to make sure they check. If you just write 12, then are you actually checking your work? No. But it does equal 12, so that's right. So that means check. We got it right. Right? If you get it wrong, don't put an X and just keep going. Go back and fix the problem. Right? Owen.
Do we have to do that on the back?
Yep. All right. All right. So, guys, I know we did number 3. That should kind of walk you through how to check the adding and subtracting. Let's see what that would look like on these multiplying and dividing real quick. So we're going to check this. All right, and guys, I can show you where I already worked these problems on my homework, and I solved, and I checked them as well. In fact, funny story, because y'all know I like rush through my work sometimes, I found a mistake when I was checking, and I was able to fix it before y'all found it, so that was exciting. Okay, so 2x equals 16 was the problem, right?
Yes.
2x equals 16. So I'm looking on this side with the x. So what was x in this problem? What did we find? 8. X was 8. All right. So now I have 8. Does that mean 28?
No.
No, we put that 8 in parentheses, right? So now it's 2 times 8. What is 2 times 8?
16.
16. Did that work?
Yes.
Yes.
Magic.
Okay. Okay. So checking the next one, guys. I'm going to check all these real quick. All right. I'm going to go ahead and check them real fast if y'all don't mind. All right. So we have 3t, which means 3t was 5. So I get 3 and 5 in parentheses, which means to multiply. 3 times 5 is 15, which matched. Okay. All right, this is one that some people have asked me about, came back and asked like during Warrior Time, is how to check this. It's the exact same concept. What was K? 12. It was right there. There was K. And sorry, I forgot to highlight that one. So K was 12. So instead of writing K on top, I'm going to put 12 over 2, 12 halves, or 12 divided by 2, which is 6. Do they match? Yes. All right. For your homework, front and back, solving. I would go through, guys, solve all of them, and then go back and check them. Because if we're doing the same method over and over and over, it becomes a little bit faster. And then go back and check over them. That's what I did. And when I was checking, I was able to fix a mistake. So make sure you check. All right. I'm going to